last time, this prevents people from flipping back and forth on their notes. I'm sure some of you are still doing that anyway. But if you are going to be flipping back and forth, because now the time constraint is shorter, a lot shorter. So for example, in one part of the test, the question will only show up one at a time. You cannot, except for the rest of it, you will see the rest at the same time. So you can choose which one you want to answer first. But you cannot go back, except for part 2, where you can actually change your mind and if you think this is the right answer, you can change your answer on that one. But for part 1, you have no choice. It will pop out once. You have the total. So for part 1, you have total of 15 minutes for about 20 questions. It will pop up. You have to answer it. Move on to the next one. You cannot go back to the first part of the first question. Then you move to the next one. You answer, you move to the next one. You don't see all the questions at the same time. And the reason for that, it prevents people from flipping the page way in advance. And then it's also short time. So once it's finished, so if you spend time opening your notes, you will run out of time. It's either you know it or you don't know it. So that's the whole point. So if you're gonna be flipping your page, finding for an answer, you will find the answer, but by the time you get to the last question, you will run out of time. So I'm suggesting that you actually do study. Prepare yourself on this one. So many of my questions, at least on the part 1 is going to be a little tough. So part 2. So that's why we're going to this, because this is pretty much what you will expect. There will be, the test will be on Thursday, starts at 9, exactly 9 to 10:30, and will end at 10:30 in the morning. You cannot retake the test. Same thing with part. Once you finish each part, you cannot go back to the part you finish. You have to sit and finish each part at a time. So you cannot move from part 1 to part 2, part 3, or you can just do part 2 and then come back to part 1. If you start part 1 or part 2 of the test, you have to finish it. You cannot go back to any of the parts. In fact, in part 1 of the test, you cannot even go back to the previous question. It will pop out. You can spend the entire 20 minutes on one question if you want, but I have 20 questions. So my suggestion is you have a minute or so to finish each question, and then move on to the next. This is it's really not that difficult. It prevents people from, and it's all randomized as well. So that's why you don't you can flip back and forth your notes. So if you intend to cheat and put the notes next to you, you will run out of time. The reviewer I gave you today will be pretty much your blueprint on how you're going to prepare. So second part, so each part will be about 15 to 20 minutes, and I might even make some of them even shorter, because when I was practicing this, literally, if you know the material, you'll be finished in 2 minutes. If you know the material, obviously. What I noticed, if I put way too much time, you have all the time in the world to go back, check the answer, and come back. So I'm making it shorter, and I'm making it shorter, and also very time constraints. And in some part, like in part 1, you cannot even go back to questions. Part 2, in part of the test, you'll be able to see all the questions. You can pick which one you want to answer first, but in the same manner, you're given 2 tries on part 2. If you change your mind, okay, I think this is the right answer, you can go back and change it. However, once you finish part 2 and submit it, you're only given twice. If to change it. After the 3rd time, you cannot change your mind anymore. Then part 2, once you finish part 2, it's done. You move on to part 3. Technically speaking, you'll finish the entire test, if you know the materials very well, in less than 30 minutes. If you know the material very well. I don't plan on, we have to submit our grades on the 11th, I think. Yeah, I still halfway on checking your labs as well as your assignments. So please bear with me. So I probably will have no time to make an essay test. So I'm still debating on that one. I might have just one essay question, and if I have to add one, it would be just one question, and your answer should be relatively just 1 or 2 paragraphs length, something like that. So but I'm still debating on that one because I'm I have to finish grading everything, put your putting all your attendance. It's just a long list of laundry list I have to do at the end of the semester, and I have to do it before the 11th, right? Because the end of the day on May 11th, I'm done. So I your attendance, by the way, for lecture is to the day we were in the campus, and after that I never really gap attendance of who's attending my online class or not. The same group of people are, I know who they are. It's pretty much the same people who are here now are the ones in my online class all the time. But out of the 26, there are about 10 who are always here. You know who you are, right? Destiny, Christian, Elia, Hector, so there's a bunch of you, Sarina, and all those you who are always literally in here. Maria Elena is always here too. So I know who you are, so it's not like but I never kept attendance. Your lab attendance is based on the lab you submitted. So Christian, I corrected yours already, by the way. I haven't just put it in there yet. So I don't know if actually that doesn't affect so much of my grading so much. So I'm not accepting any more labs, by the way. No more. Just because I'm struggling just to finish the other labs right now, and there's still a lot I have to finish on your last lab, right? Your last lab, and some of you haven't finished the ammonites. They'll be late, but submitting now is a little too late for me because I'm still making your test. It is time consuming, and I'm still trying to do some math on your grades and stuff like that. So I really don't have any more time to correct labs anymore. It's not that I don't want to correct it; I just don't have time. And I still have to prepare. I spent the entire time preparing your reviewers. Okay, let's start. Did I miss a question here? So late labs already late at this point. They're not I'm not accepting any more of them today, as of today. Here we are. And the reason for that too is if you're late in lab 3, lab 4, lab 5, I don't know how to grade those anymore, right? I just don't know if I have time for that one. I just don't have time. So let me give you some. So today, this is just like, if you're not in here today and you're gonna test on Thursday, you're gonna have a major problem. Listen very carefully and put out your ball pen and paper, because I'm giving you an insider's information now on what you will most likely see in your test. That's the whole point we're doing this, by the way. We're covering most of my questions. We cover a lot of the stuff we covered last time, but I also included a lot of the past as well. But so about 30 to 40% will be materials that we have covered already in the beginning. So let me just go back here. It is important, I'm telling you this now, to know the past labs that you did online. I want you to know the trilobites. Look at every ones you draw there, the species that you drew. And so look at them again. Like this one. This is the last one was pretty long, right? Like this one. Make sure you remember what these organisms are, right? Not that, at least up to the phylum level. Well, all the way, at least know what phylum this are. So because I included a lot of the fossils that you describe and actually draw in the test. At least in one part, it will be just all fossils. I'm not going to tell you what questions I have them, but make sure you review the materials that you've done. These are so you can literally match the specimen number here with the phylum, the class, orders, family. I don't expect you to know them, but at least know the phylum part. Know that one, know them that they're kingdom. On the gastropods and bivalve, make sure you know that this is gastropod versus bivalve. I think these are the only two critical ones. At least for the class part, make sure you can tell what a gastropod is versus a bivalve. So all this here, important. Know that one. Know also where they live. At least get some idea of the shallow marine. Where do you find them? So for example, if I show a picture of this one, what is that? What phylum is that? Or what part of the ocean would you see that? So just get some idea very quickly on your lab. Go back to your lab materials, by the way. If I show you this one, for example, make sure you know those are corals, or what we call phylum Cnidaria. If I show you this one or this one. So I'm not going to tell you which one I'm going to use, but I'm going to use all the fossils that you did for ammonites, trilobites, as well as this one in your test. So that's the first. You know that you should know the difference between what a bivalve is versus, let's say, a brachipod. They look identical sometimes. If you look at how do I know these are brachiopods versus, let's say, this one are bivalves? They're actually two different phylum, right? This is a mollusk, whereas this one are brachiopods. All of these are extinct already, whereas this one you still find them today, right? The bivalves. So please review your fossils. I'm begging you. I would suggest when you're know them by heart, at least the file. You will because of it's also all the tests are randomized, so not each one of you opening the test will have different numbering already, right? There's no way you can tell your friend or text your friend, hey, the answer to question 1, number 2 is this. No, you cannot, because each one, every time you open it or somebody opens it, it randomizes it. So the test is randomized. You cannot literally give an answer to the other person because it's different. I tried this because before I did finalize the exam, I have to take the test multiple times, make sure it's working. So make sure you know your lab very well. At least know the phylum, the kingdom, and all that stuff. Like this is a prokaryotes, right? These are sponges. This is porifera stuff. So make sure you know them by heart. Right. At least so when I show you a picture, okay, what phylum is that? And you should be able to say, no, yeah, they are phylum Ganodermata, stuff like that. And what phylum is that, for example, or what is that? Is that a gastropod or is that a gastropod, a bivalve, or a brachipod? Should be able to say, well, that's a gastropod, right? Stuff like that. This one, is this a brachipod or a bivalve? What is the phylum of this one? Stuff like that. The test is short and quick and snappy. If you start fumbling around and looking for your answer, you will run out of time. So make sure you know what. You don't do that, because it will help you for the first few parts. Then you run out of time. So that is so every lab should that did at least on the last 3 ones. Please look at them and review them. Now, this is probably critical because I have here a list of terms. So in one part of my test includes definition. Like, you should know what these terms meant. You know, and so one of my tests will be made up of definitions from the beginning of the lab of of historical geology. So, can you hear me, by the way, properly? Yes. So, so let me go through the list here. This, by the way, are all in your Blackboard, and you can print them, right? So, if you know this by heart, or at least know the definition, at least know what they are, then you'll be okay, right? So this is, let me just go through the list right here. That way you understand how you're going to write this thing down, or when you write this thing. The test is this test description and are written in great detail. You know, if your spelling is wrong, it will mark you wrong. So most of your answers are already written on the part of the test, right? So you can just literally copy it right there. You know? But again, there's so many. All of these are in there, but I'm only going to use a few of them, right? So it will take you forever to scroll through each one of them. So you will just have to know the meaning of each one of this. So for example, let's go through this. For example, the principle. So I ask you to write it in lowercase, I think, in some of the tests. So know what is these three principles here, right? This is from Steno's law. So what is the principle of lateral continuity? So Steno said this suggests that when your strata is deposited, that you can follow this for a long distance. That's what it meant. That principle of original horizontality. Make sure when you answer this thing or something like that in your exam, make sure you write the entire thing. Principle of lateral continuity, principle of original horizontality, principle of superposition. So you just don't write original horizontality, it will mark you wrong. It's not, if I were checking this myself, I would mark it correct, but the machine will make sure it marks, again, like your last time, it has to be identical to the way it's written, you know, spelling wise. It's very sensitive to spelling. I'm trying to remove that part so you don't have to worry about it, but the machine doesn't do it. So it's wrong spelling is the wrong spelling. I am not a good speller. My daughter is. She is, by the way, the humble ISD champion of spelling a long time ago. No, you cannot go back on the part one exam. You cannot go back to it. Once you've done it, you cannot go back. By the way, except for this one, of some of the other parts of the test where it's all right there, and you're only given. There's one test where you can actually change your answer. In many of the tests, you cannot change your answer anymore. Once you submit it, it's done. It literally, you have to make up your mind, know the answer, and submit it. You're given one chance. I might actually change that just to make sure you know, because some of the I know the easy ones I don't require for you to be able to go back, but the hard ones, particularly when I ask you to define something, those are hard, right? So that one I told the machine, let them change their mind twice. So there are tests that I require that I would not allow you to go back. Once you put your answer, boom, you're done. And the reason for that is to avoid people from picking into the notes and changing their mind, right? If you know it, you know it. If you don't know it, you're done. Yeah. So the last time I know people actually did look at their notes. It's just impossible to some of those tests I made. Yeah. So I don't know who they are, but I could assure you some of them are. So make sure you know this. So let me just go through this because these are critical. Because there is a section there the way there will be definitions and you have to know them by heart, right? And they're not difficult, you know. If you covered this already. For example, what is principle of superposition? Remember this one, and this one. All these three principles and how are they different? One talks about horizontality, that the one sediments are deposited, they're deposited as horizontal, right? They're you know, well, if you watch sediments settling on the bottom of an ocean, on a basin, any basin, even in lake, they always start being horizontal. That's the principle of original horizontality. The position of sediments always starts off horizontal. Why? Because of gravity, right? You don't really deposit something vertical at once. Something has to happen. Law of superposition, remember this one? Principle of superposition is when the older sediments are always at the bottom. Unless something happens, most of the unless the rock is deformed, rocks that are deposited earlier or the oldest one will always be at the bottom, and the youngest one always on the top. So make sure you know the difference between principle of lateral continuity, that sediments are, when laid out, you can follow them for long distances. The principle of original horizontality, that when sediments are deposited, they're generally deposited as a horizontal bed. And principle of superposition, where the older beds tend to be deposited at the bottom and the younger one on the top. All this pretty much driven by gravity, right? So what is the definition of mineral? What is a mineral? You need to know that. So what is this? Well, how does a mineral different from a rock? Minerals are naturally occurring natural substance with defined chemical composition, crystal structure. A rock is comprised of minerals, aggregates of minerals. What is a cleavage? These are the natural break in your mineral associated with crystal habits, or the way the atoms are arranged in your crystal system. What are crystal habits? So all this here, cleavage, crystal habit, all the way to streak. These are all properties of your mineral, right? So know what those are. This by definition. Why am I doing this? Because this is pretty much what we learned, all right? And then you need to know the difference between an igneous rock, a sedimentary rock, and a metamorphic rock. Know what that is, right? An igneous rock comes from lava. Sedimentary rocks are from erosion and deposition of sediments, right? And a compaction and cementation, sometimes through evaporation as well. And metamorphic rocks are rocks that were produced, pre-existing rocks that were submitted to pressure and temperature, and they changed to another form, right? Igneous rocks are from magma. Sedimentary rocks are from any pre-existing rocks that were deposited, either that become hard through compaction, cementation, or evaporation. So make sure you know that. What is stratigraphy? So stratigraphy is this is the one we do all the time. We've been doing for the last exercises we're working on so know the definition of that one. What's the difference between relative and absolute dating? Relative dating is chronological, pretty much the use of common sense. On relative dating, you don't really know the absolute date. So relative, for which one came first. So that's why it's called relative dating. So when you're trying to date something, which one came first? For example, if you have a layer of sediments A, B, C, D, E, the one at the bottom will always be your older one. So that's relative dating. If you have a dike that cuts through them, your dike will always be younger than the sediment it cuts. So relative dating is a process of dating a sediments through pretty much common sense, or use of. All those, by the way, are covered, and the actual definitions are covered in our previous materials. Just go through them. What is correlation? So correlation is the process by when sedimentary rocks or any rocks of the same age are matched with another. So you're literally trying to match rocks of the same age, right? And you're drawing them, as in most cases you draw a line that connects the two together. So that's the process of correlation. What are index fossils? How do you know an index fossils? Index fossils are fossils that are widespread in geographic location. They are narrow time range, and they're everywhere. So you can, that way they can be used for. So index fossil tells you best about time, and they're the one used for correlation, right? So index fossils. Look at what do we define as index fossils? It has to be abundant throughout the earth. there is, they are abundant, and they have very narrow vertical time range to be called an index fossil. And why do we need index fossils? Because we use them for correlation. So what's the definition of fossils? So just look at that. This is interesting. The half-life is written this way. What is half-life? Is when your parent element turns into a daughter. So turns to a daughter isotope, and that is the half time it would take for that parent, and the half of that parent to change, the amount of time for a parent atom to change into a daughter element. So a half life is, that's to look at the definition of those. I'm not gonna give all this to you, but I'm just going through them, because all my questions on the definition comes from this. So all this list in here, right? There's a whole bunch of them. So what is an isotope? Isotope are when you have in your nucleus, you have your neutrons of different numbers. You have the same number of protons, but your nucleus is different, right? What is like tectonic theory? That's when, it's a theory that says that continent and the plate, that the continental crust or plates in the Earth are moving through process called through convection of the mantle, stuff like that. So these are terms I will, so that you need to at least know. Find time to look at them. If you don't know any of them, make sure you check them, go back to your notes, and understand what they are. Going through each one of them might be. So my first suggestion is go through all the lists, check the ones you don't know, and go back. Go back to the definitions. Do the ones that you don't know first. That way, when you see it, at least you know it, right? So if you don't know what a P wave and S wave is, make sure you know the definition of a P wave and S wave. What I forgot to add magnitude here. There's epicenter. There's also magnitude. So know what subduction zones are. The difference between mid-ocean ridges is when new crust is created. Subduction zone is when your oceanic crust is actually destroyed as it goes underneath another oceanic crust or another continent. So to my suggestion is go through all the lists here. And here's another, this is part 2, this is page number 2. Well, it's paleomagnetism. Know at least what the definition of that is. So this is ancient magnetism. So when your rock get deposited, they usually carry the original orientation of the magnetic north. So the magnetic north stays really in the same north, but the problem is your continent is the one moving. So this one gives you an idea of where your paleogeography is located by. What are seafloor anomalies? Seafloor anomalies is when you have reversals of the seafloor, right? North-south, you develop what's called the zebra pattern. One will be pointing north here, and the other one will be pointing north in the next one. That's what we call seafloor anomaly. What is fossilization? What are the processes associated with fossilization? You need to have hard parts, has to be deposited rapidly, has to be preserved, has to be preserved from decay. Not exactly preserved from decay, but we have something that will make it preserved as a fossil. Either it has hard parts, it was deposited properly, it was deposited rapidly, or that particular organism is protected from anything that will destroy it. So go through this one. And this one, these are all fossilization process. What's the difference? So all this one from permineralization to mold and cast, these are all different kinds of fossilization. You did this in your lab. Just make sure you know what the difference is between permineralization, like the one you do on petrified wood, versus replacement, versus carbonization and mold and cast. So, a lot of this might re-show twice, right? Some of the questions I have in here may show up in one part of the test and will show up again on the other. A good example of them is this one. What are what enumerate the 4 important fossilization process? So all you have to do is permineralization, replacement, carbonization, molds, and casts, right? That's all. So some of these I actually asked twice in my so some of them are repeated. Molds and casts. What is natural selection by Darwin? We have this long lecture on this one. So just know what makes the natural selection process. What's the difference between descent with modification versus common descent? This is from Darwin's natural selection. So all this actually all falls together into. These are all under Darwin evolution, right? So descent with modification is having an offspring that will start. So it's like you having differences with your parents, and your parents having differences with your grandparents. So that modification, the ones that develop, that is important that will adjust to the environmental condition they're in, are the species that survives, right? So common descent is pretty much like a family tree, that all organisms have common ancestors, something like that. And we do, if you actually follow from the last 3-4 lectures we already did, the discussion from Paleozoic, Mesozoic, all the way through to the present, all follows what it pretty much is a history of common descent. So what is unconformity? What is this? And when do you usually see unconformity? I love unconformity, by the way. I love giving this in my test. So every time, unconformity generally develops when you have generally speaking, right? I'm very generalizing here. It's when you have when your sea level, let's say this is your sea level 1. So unconformity is an erosional surface or gap in time, or it's a erosional surface or a surface of non-deposition, 2 things that separates an older bed from a younger bed. So there's the time that disappears between these 2 beds is what we call unconformity. When does it happen? So like in many of the discussion on our so when you have a let me just erase something here. So when I'm going to lecture very quickly here because this will show up in your test. So if you have a land surface, that's a land surface. I'm just going to draw the, let's say your sea level 1 is this orange one, right? And then your sea level drop. So we call regression, right? So your sea level 2 is this purple one. So sea level 1 is this one here. And the sea level 2. So this is so your sea level originally was here. So then you have marine deposits in here, right? So you get depositions of sediments right through here, right around here. Actually, you get deposition all the way through, all the way, right? You get deposits throughout. You get sediments. However, when your sediment drop to number 2, what happens is your sea level, when your sea level drops from 1 to number 2, what happens is this area, so now your sea level is here, and it dropped down to this area here. Now this whole area right through here is subject to erosion, right? So that's what happens. And so because of that drop in sea level, that you remove some of these pre-existing sediments. So then when your sea level rises and deposits again, you have a gap in age or a gap in sediment, the deposition, and simply because that was been taken out. So unconformity is some, so you see a lot of continental unconformity, what we call continental unconformity, that separates various time frame formations, and because they, every time you go from regression to transgression, there's always an unconformity that separates them in the continental part of the world. However, in the sea, you may not see it, because even if it drops, so when sea level drops from, let's say, if sea level drops from let's say 1, then that drops to position number 2. So it drops this way. Your erosion will happen, obviously, in this area. Most of this area will be submitted to erosion. Well, this area here, where it's always underwater, you may not see unconformity. May not, just because it's always underwater. Some, so I'm just generalizing because there are actually marine transgression that, when beaches and all that stuff that can erode, right? There are processes, but generally speaking, most of your erosional process or unconformity, we call continental conformity, are in areas landward, or at least from the coast landward, right? If your area is always underwater, like if it's in the middle of the ocean and it's always underwater, then you will not see erosional surface. So an unconformity usually will not develop. So most unconformity develops land on your coastal landward. What is geochronology? So this is important, right away. It's a science that that deals with the event or the timing of events on the order of which event happened on Earth, right? I would suggest actually going through the definition of almost all of this if you could, right? Know some many of this, at least know them, so that when you see a definition, you will know that's what's I'm being asking. So what is Phanerozoic eon? So these are the earliest time, from the time the Earth formed all the way to about 0.5 billion years ago, or 540 million years ago. So that's the earliest time. But then I got wrong. Phanerozoic is the period from the what we call the so yeah, these two, so these are the eons. So the earliest time, and then of course the Proterozoic, the period when we when life starts big, from Cambrian all the way to pretty much the present, right? So then we have the three eras. Make sure you know this by heart. There are only three of them, so please try to remember these three eras: the Cenozoic, Mesozoic, and Paleozoic era. Cenozoic, Mesozoic, Paleozoic, the oldest, the middle, and the youngest, right? There are only three, and each one of them have different periods. And that's exactly what we've been doing for the last 4 or 5 lectures already. So sometimes I don't really have this in order in such a the way we lectured on this, but know what the difference between what is a strata, lamination. Also, I forgot to mention what is a sedimentary structures, crossbeds. Eukaryotes. What's the difference between a eukaryote and a prokaryotes? Prokaryotes are the first one to come in on the Earth, right? Eukaryotes are like this. They're cells. We are eukaryotes. We have a nucleus. And inside this nucleus, you find your DNA in the form of chromosomes, right? And then inside here are your cytoplasm. So it has a nucleus and with separated with a membrane. Well, prokaryotes are no, they don't have it, right? They just have this thing with the tail here and this, and all the strands of DNA like this. So this is a eukaryote, and these are prokaryotes. Just know what those are, right? You also know what is a cyclothem. Cyclothem is when you have a alternation of marine and non-marine deposit. If your sea level is, and this is very common in the central part of U.S., like Colorado, Utah. You'll see this even in all the way. And anytime your sea level goes up and down, right? So what you will have is, for example, your sea level is up here. So if your sea level is fluctuating back and forth, so first you will have marine deposits, and then your sea level will drop in here. Then the same point now will have fluvial or non-marine deposit, and sea level rises up again. So every time your sea level goes up and down, and you have this alternating. It's like a cycle of alternating marine and non-marine deposits. When I talk of marine deposits, those are deposited underwater, marine water. So that's why it's called marine, right? Limestone is a good example. Some of your offshore shale are good examples of those, right? Non-marine deposits are those that are deposited on land, like eolian, your dunes, your river deposits, we call fluvial deposits. Your lake deposits are are non-marine deposits. Make sure you know the difference between a marine and non-marine. So when you have alternating one after another, that sequence is referred to as a cyclothem sequence, right? This one, it's like a cycle of alternating. So what's the definition? I think I have more terms than this. I might add a few more. Orogeny is another term for mountain building. So make sure you know that. What are evaporites? These are sedimentary rocks resulting from the precipitation. Yes, please write in lowercase. I suggest that. In fact, it's written there in the instruction that you have to write in lowercase. I tried to remove the spelling issue or so it may not be that. Hopefully, it will not. If you write in uppercase and then lowercase mixed, hopefully that it doesn't affect it. But I have a instruction there that to write everything in lowercase. For example, like this one here, right? Mesozoic, Paleozoic era. Those are usually written in uppercase, and you have to usually write them in uppercase. But the machine will mark you wrong if you do that. So I really prefer that you write it in uppercase, but just for safety, write everything in lowercase. By the way, if I require for you to do some sort of, I will, most of these terms you will find in your test already written, and I will, just like what I just did here. All you have to do is actually make sure you look at them, but the problem is, if you're trying to figure out the definition of them one by one, and you're in the time limit, you're in deep shit, right? So you really need to know what they are already. For example, I may ask you, which of this term I will blah 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 blah, is it stratigraphy, relative dating, or absolute dating? So make sure when you know the definition at least, or have some idea what the definition is of all these terms. I think I'm missing a few more definitions here. I might add a few more, but at least start on this one. This has been, I posted this already last weekend. So so you should have seen this list already last weekend, at least as early as Saturday, I think, or Friday. So just to give you an idea. Okay, those are for the terms. This is this is the one that took me so long to do, right? And I did this for your sake, right? I summarized everything we've covered in the last COVID-19 lectures, right? During the time we are all here. So if these are just words, it may not mean anything to you so much, but the way this would mean more is if you look through them and go back to the lecture again. So if I go back to the Proterozoic eon, this is an eon. That's the period from before this one. So the Earth is 4.5, but it's too hot to do to record anything at the time. So from this time, so these are the critical events that one has to remember. Have an idea, right? If I give you a test on this one, make sure you have an idea what each of the event are associated with each one of them. There's so many of them, but 8 pages long. So I'm still trying to formulate how I'm gonna ask a question on this one. But the thing is, for example, in Proterozoic, the earliest multicellular organism first came out. The orogeny, no two things, at least for this test. Very critical that you know what are the major orogenies associated with each time frame, each eon and era. Era are so particularly the era, right? So this I'm gonna say know exactly by era. So what is this orogenesis? Orogenesis is mountain building. So if I ask you, when did would you find the Nuna supercontinent? Well, so if I ask you that, you should be able to say it happened around Proterozoic. Why? Right there. If you want to know more about Nuna and where it is, just open your previous lab, particularly the configuration of continents. So these are the events that occurred, to me at least, on which I condensed on your lectures, are critical of Proterozoic. So the banded iron formation. Remember this one, when you have alternating iron oxide and siderite iron carbonate. So iron oxide is Fe2O3. So they alternate with Fe iron carbonate, FeCO3, right? So this, so remember that banded iron formation, or some of the earliest rocks that form in the Proterozoic, because first of all, there's what it is we have very few oxygen. So every time oxygen comes out, and we have a lot of iron on Earth. Remember, the Earth is literally made up of iron and nickel, right? Our core and mantle. So we have always have iron in Earth. and so your oceanic water contains a lot of those, as well as calcium, right? What happens is because we have very few oxygen, they use the oxygen once they appear, and you have an iron, they combine very quickly to produce iron oxide. And after that, once you use up the oxygen, once you use up pretty much most of the oxygen, your iron now tend to bond more with your excess carbonate system, which came from dissolved CO2, which when you add so when you have no more of this, the iron combines with carbonate to produce siderite. So those alternating tells you an event of anoxia, or oxygen present, oxygen absent. So so banded iron are some of the earliest ones are not all banded iron are Proterozoic, by the way. You'll find banded iron today, right? But some of the earliest form, particularly the ones you find in part of Australia, banded iron, those are Proterozoic. They're really old. So some of the orogeny, this is critical. Always remember, put this in your head. Most of the early orogenies on North America are usually in the northeast part, right? All the way to Canada. Mostly in the northeast, all the way to Canada. Canada can exhibit. So the Hudsonian orogeny is Proterozoic. Where else is Grenville orogeny is Proterozoic. So so these are some of the earliest. We have the supercontinent. We have stromatolites. Your eukaryotes first appear in the Proterozoic, particularly during the Mesoproterozoic. Eukaryotes, remember, we just discussed this in our definition. These are the cells with nucleus, with membranes. And we are eukaryotes, by the way. And any cell organism except bacteria. Bacteria are what we call prokaryotes, right? So they first appeared during this time. So all this. So remember at least this. So if you're trying to figure out which are the orogenies in the Proterozoic, this one here, the Grenville, and another event that happened during that time is so there are two major supercontinents we call the Nuna. This one here, which eventually broke up to Rodinia. So these are the two supercontinents, the Nuna and Rodinia during Proterozoic. Let's move on. Because it gets more, right? As we progress to the present, there are more of this thing. So you will see also, I summarize what happened during that particular era, right? The Paleozoic. Paleozoic is divided into the Cambrian, or Division Silurian, and the Carboniferous period, right? So we have Cambrian, Silurian, Devonian, Mississippian, Pennsylvanian, which are both Carboniferous, all the way to Permian, right? So I divided them in. So if the very first part of which is the summary of the entire era. So what happens during the Paleozoic era? In summary, this is what you will see. I summarize them for you. That there are abundant multifossil cellular organisms. So these are critical one. The first primitive land plants appeared during the Paleozoic time, particularly Ordovician. Fish, the first lineage of fish came here, and then which became eventually your four-legged tetrapods. Vertebrates evolved during the Paleozoic. So these are the critical events, both from life form. This is, at least the first part is mostly related to life-related events. The second part, if you look through here, these are the major orogeny. This is orogeny, your mountain building, the Taconic, Acadian, Alleghenian. Where would you find all this? These are all mostly in northeast continental northeast US, right? And Canada, mostly in Canada, by the way. You see a lot of this event. And a lot of those also found in Europe, and some parts of Europe, all the way but we focus primarily our orogeny on North America. It doesn't mean there's no orogeny in other parts of the world. There are. We just focus on North America. What also happened during that time, remember the Earth is very young. We have shorter days, and the moon is not very far from Earth at the earliest days, especially. So we have very strong tidal effect. And also remember, there is no vascular plants during this time. So all these are summarized of what you just go through them. I don't expect you to memorize them, but go when you're flipping to your lecture notes again. This is what you will see anyway. What I've done though is condense them in such a way you can just look at them in one looking. So Cambrian, for example, is the explosion of life. This is when all of a sudden there was very little life on Earth, and all of a sudden, boom, there's an explosion, right? The trilobites showed up, and so a lot of species started coming out in the Cambrian. One of the reason for that is because now we have an Earth with have a lot of oxygen. So it makes a big difference when you have oxygen. It really starts to support life better. And not only that, many of our organisms starts to develop hard parts in their body, like shells, right? So not that so their preservation is improved too. So that's one of the reasons why we see more life form in the Cambrian. The earliest, let me just make this bigger. The earliest continent, North America, is Laurentia. It's not really the way US looks now, but most of continental US at that time, at least the ones that are falls under what is Laurentia. So like most of Northeast US, some parts of the Appalachians. The Pacific is not here yet. Remember, California and all those developed far later during the geologic history. But Laurentia is pretty much, you can say, as some or ancient North America. Part of Laurentia is in Europe, and some of them are I think some of them are so not some of North America, Canada is part of this, and some part of Europe as well are part of Laurentia. But when you want to know where North America is, find where Laurentia is at that time, and you will know. So trilobite pretty much is during the Cambrian time. Ordovician, which follows, this is the orogeny. So now I'm going. So these are just some of the things that's happening. The conic orogeny. This is again in northeast part of New York, mostly in Canada. You'll find a lot of this in Nova Scotia. But so this is some of the orogeny taking place. Associated with that orogeny, a deposition of several clastics. The jellyfish came out during that time. Trilobites became really abundant, and it's archaeocyanid first appeared during this time. Trilobites were already here, by the way. They've been around since the Cambrian, but trilobites started getting more abundant during the Ordovician. And then as we move on, then we have the Silurian. So these are some of the events associated with that. So this is pretty much a summary of what has happened during that given during era. So Devonian is the age of fish. So if I give you a series of fossils name or stuff like that, and then age, when did they first appear? like fish first appeared right around the Devonian. This is the age of fish. Amphibian first showed up in Devonian. So many of the stuff that we're seeing now actually started way back then. The Lapidus Ocean, if you want to know what this is the ocean that once separate Laurentia and portions of so this ocean is already gone, but this is the ocean due to subduction. This is you have to look at the previous map. But just to give you this, I have no question regarding Lapidus Sea, by the way, just because this is very detailed already. But this is around the origin. You remember that one? Pangaea, first the assembly of Pangaea occurred right around Devonian time, right? So when your major continents showed up. U.S. is most of North America is in the equator. Gondwana is in the southern part of the continent of the globe. You'll see Gondwana, South America. They're actually situated during this time towards the southern part. And towards the late Devonian glaciation resulted in mass extinction. Most of mass extinction during the early times, remember this, is attributed to changing climate. And so the two things that you have to remember, at least that's causing most of the mass extinction. The most mass extinction are due to changing climate, your organisms not being able to adapt quickly enough, and most of the extinction occurs during glaciation. When all of a sudden most part of the Earth are covered with ice. So another form of mass extinction also occurs when every time you take out the place of where they live, right? So if you used to live in the ocean and now that ocean is gone because of regression, well, whether you like it or not, you're going to die because you used to live in water. Now you don't have water. So those are the two common causes of mass extinction, at least during the Paleozoic, and actually all the way to the present, right? But on the Mesozoic boundary, particularly Cretaceous Tertiary time, or we have a meteorite impact that also contributed to mass extinction. But the two major ones are climate change, particularly glaciation, and orogeny associated with loss of for marine organisms, their loss of ocean, right? The not being able. And then third important one is the meteorite impact associated with Cretaceous, the extinction towards the end of Cretaceous, and of course another critical important one is intense volcanism. So those four ones are the major cause of mass extinction. So the fourth one would be like it happened in the Cretaceous as well, was so much volcanism, you increase so much CO2 in the atmosphere. And actually we have a water all of a sudden that's very anoxic and killed a lot of marine organisms as well. So in the Cretaceous time, we have two major causes of extinction. One is because of the meteorite impact, another one is so much volcanism at the two time. During the Paleozoic and Mesozoic time, most of mass extinction is attributed to glaciation and mountain building. So here is just going through here, right? Just go through this. Pennsylvanian. So when you talk of North America, Mississippian, again, this is the time when North America is pretty much in the equator, and pretty much we're in tropical condition at that time. We have significant amount that we have shallow ocean that occurred throughout most of America, and as a result of that, we have this limestone, this deposition of Mississippian limestone is very, very prominent in North America. But eventually it retreated, right? The orogeny associated with during the late Paleozoic time is the Alleghenian orogeny. It started right around. It actually started earlier than this, but most of it centered around Mississippian time. Your Appalachian Mountains and some parts of the Permian Basin is attributed to this Alleghenian orogeny. So do you know where the Appalachian Mountain is, right? So they're all in the northeast section. They go all the way from almost the southern part, southern states, Tennessee, all the way down all the way to Canada, actually. Pennsylvania, if you have to remember one thing in Pennsylvania, was this very thick coal deposits in Pennsylvania. Right? This is to remember that thing. Pennsylvania was named after the state of Pennsylvania. That deposits, the thick coal deposits associated with during the Pennsylvanian time. That's where it got its name. It's because at that time Pennsylvania was pretty much most of the of U.S. was in very tropical condition, and part of Pennsylvania. So we have the uplift here. We have significant amount of shallow non-marine to marine setting that allows swamp to accumulate. Swamp develops in areas with significant amount of humidity. So the Pennsylvanian time is characterized by, on the western edge of Appalachian, by accumulation of thick coals. In the other part of the U.S., we have the mountains, Compahagre Mountains, developed in the southwest U.S. That is in the area of southwest Colorado to Oklahoma. And towards then we enter the Permian time, Permian Basin. It's warm, arid. So this time the Earth was, particularly North America and a lot of part of Europe as well, was arid. So this is a period of major aridity. So meaning deserts, right? So we have plenty of deserts and evaporites during this time. The Pangea, supercontinent Pangea, pretty much this is the time where they became very big, right? What we call what the Bertus Pangea. The sea that surrounds Pangea is called is called the Pantalasa, the big ocean that separates the two of them. The one that separates Africa and Europe is called Tethys Sea. So these are the two major oceans when Pangea was around, right? So remember, if you have to remember anything on Permian, it was arid. We're pretty much like the Middle East, or pretty much what is Saudi Arabia right now, especially the part of West Texas, New Mexico, Colorado, and all those areas, and a lot of part of Europe actually, like the part in Norway, So this is a big time where we have a lot of evaporites and red beds. Red beds are always associated with desert deposits because of the aridity, So here it is. So Delaware Basin pretty much was submerged. So this is an area where we have a lot of deposition of evaporites interbedded with limestones and red beds. So Permian, aridity, arid desert condition, very much characterized Permian time. So after the Permian, we have major extinction again, and comes now the Mesozoic era. Mesozoic era is divided into your Triassic, Jurassic, and Cretaceous, right? So in the same way, the way you will look at this reviewer, I summarized the entire era for you right here. This is what happened during those time. What is critical about Mesozoic era? Dinosaurs, right? So this Mesozoic era is known as the age of reptiles, big reptiles that would eat your car, including you inside, right? They're big. So this is the time where we have Jurassic Park. Dinosaurs first appeared during the Mesozoic era, particularly during the Triassic. The earliest form of birds, Archaeopteryx. You remember this? You see this all the time. These are birds with like claws and the beak actually have teeth. So so those are not really bird the way we know birds now. These are what we call the forefather, the earliest forms of what we call bird. They're really not flying. This Archaeopteryx, they glide, but this is one form where so this thing doesn't really fly. They glide from tree to tree. So in summary of this era, we have the coming in of the flowering plants, or angiosperm first appeared during the Cretaceous. So towards the end, flowering plants showed up. Mammals actually first appeared during Triassic. So there are already mammals. they're just not abundant. What is the age of mammals? Cenozoic, right? So during Mesozoic, dinosaurs rule, not mammals. During our era, the Cenozoic, who rules? Mammals rules, because there are no more dinosaurs, right? So Cretaceous is pretty much warm. When you compare, Mesozoic era is pretty much warm when you compare this to both the Cenozoic and the Paleozoic era. It's overall the climate were warm. Most of the glacier, particularly around Cretaceous time, had disappeared. So if you're looking for a period where the Earth is really warm, if somebody asks you global warming, well, Mesozoic is a lot of global warming. Literally, it's warmer than what it is now. A lot warmer. In fact, we have no ice during the end of Cretaceous. Zero ice on the South Pole and the North Pole. Thus, we have sea. Because of that, sea level rose up, right? So we have a lot of sea during Mesozoic era. A lot of sea transgression, which is the norm during that time. There are also regression, obviously, always, but the transgression seems to be the norm. This is also a period when we have when most of the brachiopods, remember those wing, they look like shells, but they look like lips like this. These are brachiopods, but they're not lips, right? The brachiopods like that, and they occurred. They all declined during this time. And by the time they entered Cenozoic, most of the brachiopods have disappeared already. So they're excellent for age dating brachiopods, because we know they're mostly abundant they're actually present from Paleozoic to Mesozoic era, and then after this, the Mesozoic they started to disappear. They're not as abundant. They're most abundant during the Paleozoic period, Paleozoic era. Here are the orogenies. I said something really bad. During the Mesozoic, we have the Sonoma, the Nevadan. All this, by the way, all these origins. If you compare this to the one previous to this, most of these are in the western side or northwestern side or even the southwestern section of the continental U.S. Laramide orogeny, the Sevier orogeny, the Nevadan orogeny. All this, the formation of of the Yellowstone, the Big Battle, the Sierra Nevada, the Lake Tahoe, all those granites, all those orogeny associated with that, the formation of Basin Range. Basin Range is Cenozoic, but many of these orogenies are focused on the west part of the continental U.S., also the central part of continental U.S. Most of the eastern and northeastern section, all the way down to sections of Tennessee, even down to Florida, many of them are in the Paleozoic orogeny. You can almost tell east and west, right? The east is earlier event than the other one. It doesn't mean nothing is happening on the other side. There is always something happening, right? It's just that most of your mountain building are concentrated on this side of north. So your batholith, your granite that you find, these are significant amount of batholith that you find on California, the Sierra Nevadas, and all that stuff, all the way through. So are mostly are Mesozoic in age. They're attributed to your Mesozoic orogeny. So now, after I finish the summary here, these are all part of the summary. We're still in the summary here. Then I go to the details of each of the period associated with that era. So we have the Triassic, Jurassic, and Cretaceous. So Triassic is this one. This is the period from 252 to 66 million years ago. MYA is million years ago, by the way. So your gliding reptiles starts to show up. Dinosaurs first appeared during this time. The supercontinent Pangaea were all assembled at the beginning of Mesozoic and stuff like that. Pangaea starts to break up as well during this time. They form in the North America and Europe separated into Laurentia and Baltica. the rifting that you find, many of these features you still find in parts of Texas all the way through Florida and all that stuff. So those are associated. So you'll find this early rifting in North America, particularly on the eastern, southeastern section of US, started right around the Triassic time. You hear a lot about this one when if you're a geologist. Oh, they're part of the Triassic rifting. There are also volcanism associated with that, right? Every time you open the earth and the magma can come out, there will always be volcanism. Always remember that. Every time you have a rift and you open the earth, from if you open this part of the earth and your magma can come out there, so every time you start separating the earth, the crust, like this one here, and now your magma chamber, let's say this is your magma chamber. Every time you reef or you started separating the continents in the form of rifting, or even if you start opening up oceanic crust or continental crust, the two of them, either way, you will have volcanism coming out here. Lava. What will be that? Will be mostly basalts, right? Because they're volcanic rock. So every time you have that, you have so always associate rifting with faults, normal faults, and two things that always comes to your mind every time there's rifting. There should always be a faulting, because that's how it will form, right? You're pulling this thing apart, and you are actually allowing the magma to rise up to the surface and deposit volcanics. So every time you hear the word rifting, there's two things that should come to your mind all the time. There will be faulting, normal faulting, and there will be magma or basalts. Either they may not be able to come out all the time, but at least they will form as dikes, or they might even, if they come out, they will form big lava flow on that surface. And you find this everywhere in parts of the world. US, you'll find them everywhere too. So most of continental US were arid continental. So if you look at a lot of not only that, actually also parts of Europe, Triassic deposits in the US, particularly are mostly continental in origin, meaning they are aeolian or dunes, fluvial lacustrine. You'll find a lot of this in Utah, Colorado, West Texas, New Mexico, Wyoming, Northeast Dakota. So our Jurassic is Jurassic Park, right? The earliest bird, Archaeopteryx, came out during the Jurassic time. If you want to know exactly how the age, it's also in your lab, by the way. Can you hear me properly? Some of you have comments here. They can't hear me properly. Do you want me to make it louder? Or is it loud enough for you? I saw some comments here that I'm coming in and out. So Jurassic. So I'm gonna, in your test, I'm gonna put, if you can print, because there is a geologic time that I put in your lab. Please, can you just print one during your test? Have it right next to you. Is it cheating? Hell no. Because who actually remembers this? You're pretty crazy if you remember all the numbers here, right? I do. But you're not supposed to remember them by heart yet, because you're not. But for example, when I talk of Jurassic, you should know, that this is this period from 201 to about 145 million years ago, right? So my suggestion prior to the test is to go back to your lab material on Unit 2 lab, and there is a section, there is a area, there is actually a PDF of geologic time. Just print them, or have them available, so that way exactly when I talk about. So when which one came first. So it really is sort of a guide for you to see. Other teachers will probably not require you to do this. They will ask you. Well, when I was a student, we are required to memorize them by heart, right? I'm not going to do that. That'd be really, really cruel. But I do want you to know at least the which one came first, so that way that when I'm talking of Cenozoic time, I'm talking of this one here, the youngest one, right? And so it's really a good guide to have anyway. And I always have a copy of this, because we geologists, every time we go to an event, they give us free one of this. And you can always just go to Google this, and you can find geologic time scale, and they will always give you one of this for free, and you can print them if you don't want to use the one I give you, right? But use the one I give you, because those are the most recent one. They always change the number every now and then. They adjust it. So Mesozoic includes Jurassic, and there is one sea called the Sundance Sea that was present during Jurassic in the North America. They have regressed towards the end of Jurassic, particularly, and then so we have a deposition of non-marine deposit. You'll find this in Utah, mostly the Morrison Formation. I have mapped this actually too. Really cool, because there's a lot of dinosaurs in them. They found most of these species of dinosaurs in the Morrison Formation. This is in Utah. So Western U.S. Experienced a lot of what's called transgression regression of sea. What they produce out of this cyclothem, right? Every now and then. So limestone and evaporites are formed as well. You only form evaporites when the condition is arid. It has to be hot and very low humidity for evaporites to form. If it's raining all the time, you will not get evaporites. So you have intense evaporation, and mostly your ocean basin has to be isolated. It's like it has to be separated from the main ocean for evaporites to occur. They were common in Jurassic time. Jurassic is also a period of a lot of evaporite formation. Why? Because many of the Western U.S. flooded by shallow sea. Evaporites in the Gulf of Mexico, what we call the Luan salt, and the Norfolk Aeolian sandstones. You find this in Texas, in Alabama, Mississippi, underwater now, obviously, but about 10 to 12,000 from the seafloor. So if you drill just off Alabama, Louisiana and Texas, if you drill right around up to 12,000 feet, you will see what we call desert deposits. You'll find what called Luan salts. These are salt deposits, mostly halite with some form of gypsum mixed in. And it's because this part of North America became such a basin, and that basin separated from the main ocean, and because of the intense evaporation of the water, just constant evaporation, you produce the evaporite. So most of the salt that you find in Texas, those big stuff, the one you find in Humboldt, underneath Humboldt, Texas, are Jurassic deposits. They result from the aridity and regression of the sea. Cretaceous is the end of your Mesozoic era. And what happened here, we have the appearance of the first flowering plants, right? So if you don't expect flowers during Valentine prior to this, because there were no flowering plants, so instead of flowers in your Valentine, if you were around Jurassic, if you were prior to this, all you will get from Valentines are the pine cones. That's okay. So so you won't get your Valentine your flowers not until Cretaceous time, but that is if your boyfriend doesn't get eaten by dinosaurs. So sea level started really rising right around Cretaceous. This is the time when we have an ocean that connects Gulf of Mexico. When you talk of ocean, the Gulf of Mexico, if you ever go to what is that part in Texas? The one where the ocean is closest. That's Gulf of Mexico. So Gulf of Mexico at that time connects all the way to the Antarctic water in the north in Canada. Imagine that, right? You can literally go boat riding from where I couldn't remember that part of Texas. From there, all Gulf of Mexico, all the way to the North Pole. They're connected, right, in the middle, and literally the continental U.S. is separated. Well, the western side, like California, there's an ocean, and some parts of Colorado, where actually there's cannot. So if you're going from Colorado, let's say to let's say Arkansas, or even some parts of you cannot, just because there's an ocean that separates the two at the time. You can, it's impossible to do that during the time. Anyway, there are no humans anyway during that time. But there is a big ocean that separates the two. It connects the Gulf of Mexico to Canada, to the Arctic Ocean. This is also a time when you see a lot of chalk. Limes. Remember you described this in your lab. This is the white chalky material that made up of coccolith. So most of the Austin chalk, the formation you see in Austin that got exposed there as you were driving, those are all chalk. Those are a result of this shallow continental sea. They're mostly made up of coccolith. You find this all over North America and Europe, as well as some parts of South America too. This is the time of chalk deposition. Cretaceous is mostly a lot of this. So if you ever see a chalk when you're driving, it's a chalk, or a guide tells you, oh, these are Austin chalk, or this is just tell them most likely that's Cretaceous in age. Just say that, right? And so you impress them. It's probably true. We have reef builders during those time, particularly in Texas too. You will see a lot of reef builders, but they are made up of bivalves. They're not, so they're called rudists. They look like pine cone, like that, like that, like this. These are rudists. They have actually a cover up here, and they're bivalves. They're not eggplants. They're actually rudists. And then towards the end of Cretaceous, we have a massive impact. Bam! And killed a lot of organisms. So this is the cause of extinction that separates Mesozoic to Cenozoic. And comes the Cenozoic period, which is us, from 66 million years ago. So the number is 66, right? That's the key number to remember between what is separating Cenozoic to present. If you cannot remember that, just remember Satan, which is 666, and then just remove one of the 6 out, right? Just take this thing out, then you end up with 66. So we all die. Prior to that, there's a major bolide impact that killed a lot of organisms. Then Cenozoic comes in. So this is the age of the mammals. This is modern plants and animals that we see now came towards this time, during the Mesozoic time. So mammals, this is when mammals rule the earth. So unlike Mesozoic period, Cenozoic is a period of relative cooling. So we are actually, on general speaking, particularly Pleistocene is the coldest one, right? A lot of glaciers covered the earth during the Pleistocene time. So when compared to Mesozoic, the Cenozoic era, which from 66 million years, is relatively cooler. It's colder than it is, because there were no glaciers, particularly during Cretaceous time. So we humans literally came out during this time. So Flintstone, when you have these cartoons with dinosaurs and humans being together, oh, that's not true, right? There's no way the two of them will coexist, because we never came in towards the end of the Cenozoic era. We're very, very recent. Cenozoic era is divided into 3. We kind of like to divide everything in 3. I don't know why. So the oldest one is called Paleogene, Paleo, ancient, Neo. Neo is actually means new, right? The Meso is actually the meaning of middle, but Neogene is the middle period, Paleogene, and then Quaternary, which is where we are from Pleistocene to now, is Quaternary. So those are the three main division of your Cenozoic era. What characterized the Cenozoic era the most? Here they are. The Atlantic Ocean, the one on the side of the eastern side of the US, that big ocean right there that separates us from Europe. If you dive down there, there's a big mid-ocean ridge called the Atlantic Ridge. They started widening right around the Mesozoic time. They have opened up already during the Mesozoic period. So the ocean was already there, but they just didn't spread out. They become even wider during this. So what also happens is Antarctica, that island, that ice, the glacier-rich continent in the southern part of the Earth, completely separated from Australia. So the Antarctica became a completely separate continent and kind of perched underneath the South Pole, covered with ice. So San Andreas, so some of the major ones, and just made, there's obviously more to this than what I put in here, but I'm more focused in North America. The San Andreas fault system that you see that separates North American plate into the Pacific plate, all evolved during the Mesozoic, during our time, during the Cenozoic era. Those are fairly recent. Glaciation, they have a lot of glaciations, led to regression. So every time you have ice on the form, if you have water in the form of ice, you lose many of the water in the ocean. So all of a sudden we have regression. You see drop. So there's a lot of regression during the Cenozoic era. Oh, but it's not always regression, right? There are times if you go to Louisiana, you actually many parts of the ocean right now are in transgressive phase because we're already melting many of the ice. So we're going into the period of transgression. Actually, right now we're at the present many of our ocean are transgressing. But during the early Cenozoic time, particularly Eocene to Oligocene and some parts of Pleistocene, there's more regression there than transgression. The result of this is critical. This is, if you look to this, because what happens is the overall cooling, particularly in North America and some parts of, particularly in some parts of Africa as well, and mostly parts of Africa and Europe. We changed from this major lead of cooling, we lost this, the temperate plants are replaced by grass, right? You may not think that's critical. When you start losing some of the temperate plants that you used to have, they're all replaced by San Agustin grass, stuff like that. Well, a lot of things will change. So they will start to control evolutionary process. We human beings is a byproduct of that. The change from primarily temperate plants to grassland. Now our ancestors, instead of climbing up on trees to trees and all doing that stuff where they used to live, well, they're replaced by grass, so they cannot climb grass, right? Try climbing a grass and there's no way, unless they're bamboos, right? Bamboos are grass. But I'm not talking about. So what happens when you do that? So most of the tropical plants are retreated towards the equator, but many parts of the continent are now become grasslands, and because of that, many organisms evolve into chewing grass, right? Like the cows. Many of them actually adapted to chewing. So the teeth change, the skull change, everything change. If we human beings start eating just, let's say, specific, if we just eat meat from here on and we stop eating vegetables, then we will evolve through time, through mutations, and we will start developing fangs, like really big fangs. And our face will start to change and all that stuff. If we keep doing that, so so a lot of animals change in their adaptation to chewing grass. Not only that, because now the way they move too, like the horses, now they have to run across big prairies of grassland, and they have to chase things. So the way they move had to change as well. So their limbs particularly change, and hoofs, those things that are, the development of hoofs on horses start to evolve during this time. Why? Because of the change so with adaptation. So those that mutated and be able to adapt are the ones that survive. Birds also changed dramatically. From remember those gliding birds that you see, their bones became hollower and lighter, so and they now can start to literally fly. So then I go through all to the three major ones: the Paleogene, the Neogene, and the Quaternary, and you'll see them. So many of the orogenic events associated with Paleogene, let me make this bigger again, are this here, right? Most of the events are occurring in the western side of the U.S. So most of the orogenesis that you will see in Florida, there's nothing but carbonate deposition. Gulf of Mexico, we have a lot of delta. So if you actually, most of those have become really great high oil deposits. Gulf of Mexico, including most of Texas, Alabama, and Mississippi, Louisiana. If you drill there, particularly most of the Paleogene deposits are deltaic deposits, sandstone associated siltstones and shales. Lakes and rivers are most of the interior part of U.S., particularly the areas of Wyoming, Utah, and Colorado, were still continental. So you see a lot of primarily lakes and river deposits. Volcanism became fairly widespread in the western side of the U.S., particularly here. So the formation of this area, volcanism, this has tremendous significance because the basalts that you find, the cascades in some parts of are a result of this volcanism. They started here, but they continued on to the Neogene, right? They didn't stop at all. So all this subduction on the western side of continental U.S., if I can show you here, this subduction on the west side, this is the Pacific plate going into this, what used to be continental. This has tremendous impact in the western side of the U.S., all the way to Mexico, all the way to actually Panama, right here. Because this resulted this went in from Paleogene to the present, actually. Is all the Basin and Range province, all the Colorado uplift, and all those are all the result of this subduction in here. All those erosion associated with those subduction on the western side of the U.S. are the reasons why you see all this normal faulting that caused the Basin and Range, the uplift of the Sierra Nevadas, this formation of the batholith in Lake Tahoe, Yosemite, in parts of California, North California, and the basalt rich deposit that you find in the Columbia Plateau and in the west section of Washington, and the Cascades volcanism, all associated with the subduction western side of continental U.S., particularly the Pacific plate and the Fossil plate. So almost all this, and also what is critical in here is the Himalayas, the collision of. So I'm going out of North America now. So when did India collided with Asia? It's right around the Eocene time, so it's actually during the Paleogene time. So this collision that created the Mount Everest is all happened during the Cenozoic era, right? Particularly during the Eocene time, and it's still going on up to the present. And then we have the Quaternary, which includes the Pleistocene. The Pleistocene is an event of major glaciation. And because there are glaciers and ice everywhere, animals and human beings, actually, early forms of human beings, were able to migrate. They crossed the Bering Sea, they crossed Australia into Indonesia and British. So they were able to walk into the sea simply because there is ice between, instead of swimming into the. So many of these mammals were able to migrate during this time when there are land bridges associated with glaciation. The increased rainfall, there's increased rainfall in the Basin Range province. So if you ever go to the Death Valley, the Owens Lake, so you see all this Basin Range in Nevada. Though there are a lot of ancient lakes in there. If you actually, those lakes were the result of intense rain during the Quaternary time, particularly during the Pleistocene time. So that valley at one point, and many actually of the Basin Range were once upon a time covered by lakes. So those occurred during the Quaternary time. Part and northeastern part of Africa are at this time are before then were really fertile, and eventually from Quaternary to now they become dry. So the areas where we see a lot of, if you ever see pictures of people in Africa starving to death and all that stuff because of desert condition, a lot of this is a result of this, the drying of this part of Africa. So what used to be an area where they can plant something that they can eat now became dry regions. So one of the reasons so you can tell how climate even affects lives of human beings. So at the end of glaciation towards the end of Pleistocene, glacier starts to melt, sea level starts to rise. That's where we are now, starting to rise, and it's rising up even faster because we're actually melting the ice as well faster now. And Quaternary is also the period when we human beings starts to evolve, from the basic looking apes. We came towards the end of that time. So and as most of the climate zones in northern hemisphere shifted southward at this point in time. So this is pretty much, I just covered a review process of what is covered towards most of the so what I will do here in my test part, which I'm still writing by the way, is I'm gonna make sure you look through this again, because what I will probably most likely do is use a either enumeration or matching columns, or may ask you to enumerate which of this orogeny is associated with this era, or which of this event when the first archaeopteryx showed up, stuff. So it's like I can do column matching, or I can ask you to enumerate things. So this is how I will use this reviewer. Just go through them. And if you have a hard time visualizing what these are, go back to your notes where there's actually a picture of the continents. I think I'm pretty much, so this is a summary. I showed this this is already in your reviewer too. I'm gonna put this in your reviewer, but you will find this in the materials I sent you already in the past. So this is sort of a roadmap that tells you what happens from Paleozoic, Proterozoic, Mesozoic. So you can literally see what right through there when they occur. And so, however, this is more of a cartoon-like model, right? I'm gonna ask a little bit more detail than this cartoon, but this sort of give you an idea what's going on. So I have written part 1, part 2, and I'm in the middle of part 3. Part 1 is of the test is, I'm not gonna tell you what it is being able to is being able to show, I'm going to show you something, or you're going to have to define something very quickly. Second part is definition. Third part is a combination of enumeration, so stuff like that. And the fourth part, I might end up with fourth part. I might ask you to, I don't know what I'm going to do on the fourth part yet. I really don't know yet. I'm thinking of giving, and then finally maybe just one question on an essay, and I will be the one asking the question on the essay, right? And I may ask you very quickly. I don't know what I'm going to ask there, So I might please know a few things. The exam is on Thursday. The finals is on Thursday. Everyone, are you still all here? I will send you an email. Our final exam is on Thursday, starting at 9, ending at 10:30. Will there be a makeup finals? No. Let me know now if you cannot take Thursday, and because then I can give you the exam. Well, no, take it Thursday. And the reason for that is I have to give your final grades on the 11th, so I cannot delay the test anymore. In fact, I should have given the test today. Many of the historical geology tests as now ends today. I don't know if there are other professors who's doing it on Thursday, but I know Professor JF, and at least I know 2 or 3 professors teaching historical geology who's giving the finals today. So I'm not doing that. I'm giving you the instead of that, I'm giving you a sort of a review process here. Yes, Daniela, the exam will be on Thursday from 9 to 10:30. All parts will be in time. First part is only 15 minutes. It's short. You cannot go back. Second part will be definition. This one you can actually change your answer, but all of them, once you start sitting and doing the test, you have to finish them right there. You cannot go back, particularly on part 1 and part 3. You cannot go back and change your answer. In part 2, you can do it at least once. Once you submit it, last time also I have an issue. I think who had that issue? I think Hector. I don't know who asked me this question. I think couldn't remember who had this issue last time, but I finally figured out what's going on. So last time I had an enumeration, so where you actually treat it, so I enumerate 4 processes that cause fossilization, for example. And last time I noticed that if you make one answer wrong, it marks everything wrong. And so I figure out what the machine was doing now. So I might still give you that type of question. But this time it's not going to do that, right? I forgot who asked me that issue last time. So that would be so there will be enumeration in your test. But this time, if you make one question wrong and 3 answers correct, it will grade the 3 answers. And so I know what has happened now. You have to assign percentage apparently for each of the answers. If you don't, you have to make it will mark you wrong even if you only have 1 wrong answer out of the 4. So the part 3 will have a lot of enumerations. So you have to know, for example, orogeny. What are the events associated with a given period of time? You have to know what causes fossilization. What are the 3 you have to know evidences for plate tectonic, for example. Anything so part 3. Part 4 I don't know yet what I'm gonna do. Part 1 and part 2 and part 3 is already being written, so I know what that is. So each part you have to finish and done. And after you finish the entire thing, it forces. Well, if you're not finished in an hour and a half, by 10:30 it closes. It closes. Your test is done. Whether you're in part 1 or part 2, if you came in late to take the test, let's say you came in at 10:30, you cannot take the test. It's done. You get 0. So Daniela, I'm not sure actually. Yes, I will probably ask you to put the answer on Blackboard instead of emailing it to me. Apparently, my department head said that you can it's best that they put it in Blackboard than you emailing it to me. I am not really sure whether I'm going to put an essay yet, so I'm still debating on that part. The reason for that, I'm still. It just takes so much time to read what you wrote, especially some people here writes a thesis actually, which I like, right? I really like those, except it takes forever for me to correct them. Please ask me questions now. How many points will be the end of the semester? So I don't know how many I have now. I have to add it up. Can I come back to you on that one? Daniela, can you say that again? I missed your question. Daniela, what was that question? So I might actually, okay, I don't know. So we'll see. I might ask us very simple, overgeneral essay type questions. I really like. By the way, your essays were really, really, really good. I would say 80% of the people who submitted their essays, I enjoy them because it really shows that you learn something. It does. I can only give an essay test. I would do that. I have to tell you, part two of the test is hard. Uh, just because you really have to know. You remember that part that you have to know the definitions. That list I gave you. Make sure you review them, and that's an insider information already. Part two is hard, and that if you don't study. If you don't know the definition of fossils, you're gonna screw up this test. If you don't know what plate tectonic is, you're gonna fail this test. Stuff as simple as simple. Some of the definition I put in there are critical to understanding historical geology. And if you don't know some of the basic ones there, most of my questions are mixed. On the part two is everything from the beginning. So that's the only part where I have a lot of early definitions that you have to understand. You need to know what is cyclothem, right? You need to know that. You need to know what principle of original horizontality, superposition, the differences between those three. I'm telling you, there will be questions on that already. There will be questions on fossilization, like the last test. Look at those as well. Make sure you know what a rock, a mineral is. You know what a color hardness is, right? If you don't know what those are, you will fail the test. So some of the very, very, very basic things that we already covered, you need to know. So definitions of what is transgression and regression. When the sea is going away, exposing your surface, and if you're regressing, you're exposing your continent, and if the sea is transgressing, the sea is going into your continent. It's going inward. So you should need to know those, right? If you don't know those, oh, you're in trouble. What I haven't done yet is. And I might include this is your correlation. So I haven't done any tests on the correlation yet. I'm still debating on that part. I mean, make sure you still remember your relative dating. I gave that tweet twice already. I gave that in the first test. I gave that again in the second test. I don't know if I'm gonna give that again on the third test. But make sure at least you still remember how you do your relative dating. What is half-life? Half-life can be spelled as half dash life. That's how it's actually written. So in your test, if you put half and life, two separate ones, I would consider that. Hopefully the machine considers that. But technically the way you should write it is half dash life. Something like that. By the way, make sure you have the app that I gave you, Remind. This one, Remind, get it. Because if you're going to email me questions while you're taking the test, I may not be opening the email, right? So it's much faster if you have the app called and then join it. And if you have questions where you're taking the test, just text it to me, so then I can answer quickly. It's actually the way it does it, it's just like texting. It tells me that someone's asking a question. So while taking that, by the way, I forgot to tell you this. There is a password for every time you move from one test to the next. I will give the password. So right now you cannot open it anyway, and you need to know the password to be able to open the test. I will give you the password the night before on Wednesday night to get in, and you will use the password. It's the same password every time you go from part 1 to part 2 to part 3 to part 4 of the test. And the reason I'm going to give that to you is so that you don't let other people take the test for you. you may be able to open the test, but you won't see the test because you don't know the password. So I won't be giving the password until like the day before the test, like on Wednesday. Yeah, Maria Elena, I got your lab, by the way. I got your lab 15. Don't worry about it. I got it. Please ask me now anymore. I still have not written part 4 and part 5 of the test. So I'm not telling you there's no essay. I'm telling you I may not put it there, but if I change my mind, I might put it in there. The total points that we have now, I don't know. And the reason I don't know is because I think I know it in the beginning of the semester. I think it needs to be about 1,300 or something. I forgot how, 900, forgot something. But since I started adding points to like your lab 15, instead of 10 points, now 20 points. And I started adding, other stuff in there. By the way, if you did, if it gave a bonus points, that's a bonus points, right? That's not added into the denominator. It's already added in. It's going to be added to your total points. So it's nice to have bonus points. Your assignments are bonus points, not a lot, apparently. So I was told that just by my department head that do whatever you want to do with the assignments. So I'm gonna give them just bonus points for those who did it. If you don't do your assignments, those trilobite question, no big deal. If you're already 100 plus and you don't want to do it, don't worry about it. However, if you're struggling, don't submit it now. That's too late, right? But that would really help too. I don't know how many points I would add in there. And maybe just add a minimal of even 5 or even less than that. But they do add up very nicely. By the way, it makes a big difference when you add 4 or 5 points to your total points. so I'm hopefully by the end of before Wednesday, I would have all your lab graded, particularly the 15. The lab 15. Many of you, I hope you did not forget to add the summary there. Some people did forget to put, they just drew something, right? And then just copied the file and but a few of you never really, if you read the description of how lab 15 would have been done, I asked you to put a summary on the phylum, right? How they live and all that stuff. Because that's more critical to me than to know what bryozoans, how they live, what they look like, right? Yep, yeah, right, Daniela, yeah, right. It pictures and summary. That's all there is. If you did that, there you go. You got 20 points quickly. I am very, very lenient on grading the labs, by the way. I'm very, very lenient. I'm a little stricter on the final test, particularly on time. And the reason for that is to avoid cheating. If I think that I put too much time on some of the tests, I will actually start even making it shorter time. Because literally, if you know the answers, like some of the fossils, oh yeah, that's brachypod. It should not take you 2 minutes to figure out what that is. It only takes you 2 minutes or longer if you're looking for your notes and trying to figure out what it is. So I don't want that to happen. So if you know, for example, that this is a coral and it's a cnidaria, there you go, you should know it. If I ask this, where do they live? What is this? What's the difference between a brachypod and a brachypod and a bivalve, for example? One has this and one has this. Which one of these two is a bivalve and which one is a brachypod? You should know that already. You should not spend time looking at your notes. I know some of you will still do that anyway, but I'm going to penalize you by time. If you keep doing that, you will run out of time. That's why I'm making some of the tests shorter, a lot shorter, and you cannot go back anymore. Just because it prevents people from literally going back to their notes and just writing down what I put in there. And then I will be around during test time from 9 to 10:30. I will be literally. I might open the test itself on my part, so that way I know. So if you have any questions, and I can answer them very quickly. Hopefully, we have no issue, because I've been running the test myself. I'm taking the test myself, and then so far no problem. At least on part 1 and part 2. I had problem with part 3. I just realized that if I make some of the questions I have in enumeration, if I give three correct answers out of, let's say, five, and if I make only one answer, if one of my answers is wrong, I'm always marked zero. So I figured that out already, how to get away with that problem. I'm missing a whole bunch of people in this review process. I have five people who never make it to this one, and I don't know if they're going to be able to make the finals. It's too bad because they didn't drop, right? So whatever grade they get, right? No, yeah. So that's too bad. That's too bad. If they really they should have dropped the course if they know they can't make it. I have a few people who never showed up anymore, and they never drop as well. I don't know if they're gonna take the test. And if they do, they're gonna struggle because practically, if you're here, you would be passing my test because I'm already giving you the answers to most of my questions. There, everything I covered will be in the test already, especially the definitions. Please ask more questions right now. So hopefully by the time you finish, that's why one of the reasons why with this, it's automatic grading. You're gonna know you which questions you is correct and which one is wrong, right? When you as soon as you finish, I think. Actually, I'm not sure about that, but I think it does because when I was taking the test, it gives me which one is wrong. Once I finish that part, it already gives me my grade very quickly. I hope it does that too. So you know, I prefer that actually you don't see that, but maybe it helps you to know. So this one thing nice about the Blackboard is I don't have to come and sit in, look at your paper and check them one by one. The computer does it for me. So at the end of the test, I have your grade, and it's unbiased, right? Whatever your grade is of course sometimes the program screws up, like the enumeration sometimes. Please ask me now because I already spilled to 11 o'clock now on the time. I'm gonna send a detailed description of what you need to do before the test. It starts at 9 and it's at 10:30 on Thursday. There will be a password, and I will give you the password the day before. You will receive an email. So by the time you get to the test exam, you should have received an email telling you what the password is. There will only be one password for every part, so it's the same one. So let's say the password is Arial, but that's not really true, right? So you just have to put Arial in every time you open a new test. That one, but I won't give that to you until like the day of the test. Or you'll receive it the night before you of the test. You won't be able to open the test until at exactly 9 o'clock on Thursday. It only opens at exactly that time. So you cannot come in at 8:55 and take the test. You have to come in at 9 o'clock and take the test. Please try not to be late because it closes automatically at 10:30. Finish or not finish, you're done. It's almost similar to the ones you did last time. Last time I gave you so much time to do something. This time not too much. So far I have really good grades. My students are really doing. I hope all my students are in the future are like you. I don't know if they still let me teach at San Jacinto. I really hope I could still teach there. But some of the professors were telling me, yeah, that's usually the case. The first time you teach, you also seem to get really good students, and then it drops, and then eventually through time you'll have really, really bad students. And so I'm quite happy actually. Most of my students, and I always tell this to my wife that I'm very lucky to have some really, really good students who really wants to learn. And I know who you are too. I know most of the people who are really here and trying to understand what's going on. Although I talk a lot and I tend to digress significantly. You probably noticed that. I tend to talk to myself a lot too, by the way. So yeah, that's just the way I am. And also have a lot of life experiences being a geologist. So I always try to interject those things whenever I'm lecturing. But I'm pretty happy with today's with my class. I have really hardworking, good students. You know, but on average, actually more than average, I would say close to 85% of you are really good students. Well, maybe more than that, right? Most of you are really good. I have only a few that are, okay. But generally speaking, you're pretty good, and I'm very happy. So by the 11th, make sure you look at the grades that you have. Once I finish them, I'm gonna grade them all at once. Get them all done, calculate them. Your lab grades, you should be able to open all of them, and the total points. The way I don't know how I do my own math because the bonus point should not be added in the denominator, so I have to remove that. If you're doing the calculation and you're doing the denominator, your calculation will always be lower than what I'll be calculating. Why? Because you are going to be adding up the bonus points at the bottom in your denominator. So so I probably will not curve just because my average right now for the entire class is like closer to 83. That's B. That's pretty high. You know, I have a very high average. I think I have probably some of the highest average right now. I have 6 to 7 people with A, some A plus too, not just A, right? These are people who with grades of 95 and higher. I have 3 or 4 people with grades of 100. So I mean that's awesome. Right? Those are of course the students who are constantly making really good at their labs, constantly making very good in their. But on an overall, my average is around 82.7, I think, and it will probably even get higher after this exam. We'll see. Make sure you review the definition because that's the hardest part of my test. The list that I gave you, make sure you know those. By the way, and don't print them somewhere and read them because you have I'm very tricky when it comes to this thing. It will drive you nuts. So we'll see how we. So just make sure identify the definition you don't know. Look at them in your lab or in lecture notes. If you don't know what fossils is, go back to the fossil lecture and look at them. Start with the ones you don't know and then move on to the ones you know afterwards. It saves you more time. When you check the ones you know, oh, I know this, I don't know this one, I need to check this one. So you know those times. All right, you have no more questions. I'm gonna sign off, and I'll see you on Thursday. I'll be sitting here. There will be no class, but I'll be waiting for questions that will arise. I'm sure some of you will, like during that time while people are taking tests, they had issues. They cannot open their test, and sometimes they get kicked out during the test. I don't know why they get kicked out. So I will be around to just so that it's like me being there to you while you're taking the test. So if you have any questions, make sure you text me. Okay. Know what half-life is. Yeah, remember we had 2 tests already with half-life. One is on the first part where you all messed up, and then I gave it again on the second exam, right? But most of you did it correctly. So just know how it's done. I may not ask you to calculate anymore, just because it takes too much time sometimes to do that. I don't know actually, but I don't know whether I'm debating on not putting it in there anymore. If you have any more questions, text them to me. Otherwise, I'm gonna sign off, and this is it. You probably will not hear my voice anymore. Well, I hope you do. That means I died already if you don't hear my voice. And if you have any more questions, what is remind code? So there will be a password for the test. I don't know what the remind code is, but so I'm gonna send you an email detailing what your finals, the requirements for your finals will be. Right? I'm gonna give you a yeah. Thank you, Elia. I don't know exactly what the remind code is because I never. Are there any things that you find it difficult? If you have, is there anything that you would rather not see in the test? That you will find it very difficult? What are the things that you struggle the most at this point? One of the problems we have with all this COVID thing is the lecture starting on the geologic history of the Earth, which is I started from Proterozoic to the present. They're not as fun to do when you're doing this. Okay, Hector, I got you. Hey, if you don't have the app, please get them. So that way, when you're taking the test, you can, if you're having problem getting in, you forgot the password and all that stuff, I can text it to you, right? So I will give you the password and all that stuff. If you have just, it's a lot faster. Remember, we have time limit. If by 10 o'clock and you're still having problem getting into the test, that's very bad. You may not be able to finish the test at all. So let's make sure. Let's just. Why don't I just make another dummy finals? Just one or two questions. Dummy. It has nothing to do with the test. Please see if you can do that. I'm gonna have it tomorrow morning. Will be posted already in your Blackboard. This is, I would call it trial final test, just to make sure you can get in. And I will put a password there. And then the password will be SAND, ASSAND. That's not, by the way, your password for the finals, but just for the dummy test. So I'm going to tell you and email you go in. I don't want, a few of you can do that, just to make sure that you can access your final test. If you don't do that, if none of you does it, then I would never know if we will have problem in your finals, right? I want to make sure that what I did is in fact can be viewed during your final. I want to make sure that your test is really available on Thursday at 9 o'clock and it will end in 10:30. What I don't want to happen is all of you go into the test and none of you can open it, right? It's like, oh shoot, this is a problem. I would like to see that there's a problem now so I can fix it. And I will never know that actually until you do it yourself. So the only way I can do it is by trial. Now, so I'll send out a dummy test. I have questions regarding Brad Pitt and stuff like that, or something sillier than that, and see if you can answer it. There's no point. Some people ask me if they get extra points for answering the dummy test. No extra points. That's just intended to see if you can actually access the test or not. All right. If you have no more questions, I have to say goodbye, and I'll see you on Thursday. Well, I won't see you on Thursday physically or even like this, but I'll be around while you're taking the test. Make sure you download accept the invite I have for Remind. Make sure you have that, so you can always talk to me if you have a problem. And if you do decide to do geology in your future, other geology classes, other than this one, always feel free to ask me questions. If you end up taking geology, let's say in University of Houston, and you have issues, like, you can always come to me. Actually, you can come to me for anything in science related, right? You can, that I can help. But particularly if you have issues with if you're taking another geology class from another professor or another geology class from another colleges, or any stuff like that, and you need a little bit of help, just email me, yeah, and I will help you out. Right, I'm always here to help you. Financially, I can't do that. I have a problem with that as well now. All right, I'll see you and have a great day. Be safe, as always. And I'll see you on Thursday. If you have any more questions, email me. All your grades should be available, the day after your final test. Maybe by Friday. Hopefully by Friday, I would have everything graded, and you can see if you have that. I'm gonna have it earlier done, so that way when you have issues, you can always tell me. Dr. Maliksi, how come you graded me wrong here, or stuff like that? How come I answered 3 correct and 1 is wrong, and you graded me 0? Stuff like that. So I'm gonna have it graded quickly, and if you have issues, make sure you ask them. Tell me as soon as possible, so I can correct them before I send your final grades to your to the department. Okay. Enjoy. If you have any more questions, just email me. Thank you. I have a great time, by the way, with you guys. I hope I have students like you in the future again. Bye bye.